Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. We've got a whole bunch of new derived rules, a bunch of proof conventions, things that make our proofs simpler. So let's take all of these, put them together, and start deriving some more theorems. The first one is about the interaction between necessity and disjunction. So we are going to prove that if either P is necessary or Q is necessary, then the disjunction of the two is going to be necessary. So since this is the fourth theorem of system K that we have proven, I'm going to call it K4. We may make reference to it in the future. So we start off by noting a couple of propositional tautologies, namely that if P is true, then P or Q is true. And if Q is true, then P or Q is true. Now, our first derived rule says that if you've got a conditional, you can stick a box on both the antecedent and the consequent. So we're going to do that on both the first line and the second line. So, that should have been a Q. There we go. So we have that necessary P implies necessary P or Q, and that necessary Q implies necessary P or Q. Derived rule 1 applied to line 2. Now, okay, ordinarily I would say there's a propositional tautology that you can use by our convention. We don't have to write it down, but I will write it down actually just over here in the corner so that you can see what it is. So if you have that, say, P implies Q, and you have that R implies S, then you can get from this that if you have either of the antecedents, you have either, that should have been an either of the consequence. You can see now how this will be relevant to the particular proof, because we've got two antecedents, each of which actually happen to give us the same consequent, and we all know that Q or Q is just equivalent to Q, and what we want is a disjunctive antecedent, so we can use propositional logic to put together the fact that we have that necessary P leads to necessary P or Q, and necessary Q leads to necessary P or Q. So if we have either one of these, then we can get our desired result. So propositional logic 3 and 4, and the propositional tautology being used is this one. Now, the important thing about this theorem is that the converse, going from necessary P or Q to necessary P or necessary Q, is not going to be a theorem. It's not provable because it's not true. And I can give you a very brief model that shows this. That doesn't need to be reflexive. So at this world, I'm going to show that this entire formula is false. And we will have this by showing that the antecedent is true, so necessarily P or Q, but that the consequent is false. Now, if we have a disjunction that's false, this means that both of the disjunctions have to be false. For necessary P to be false, there's got to be some world that we can see where P is false. For necessary Q to be false, there has to be some world, not necessarily the same one as the first one, where Q is false. Now, if we make Q true at the world where P is false, then we have P or Q. If we make P true at the world where Q is false, then we have P or Q. So now it is in fact true that P or Q is necessary because every world that this world, let's call it W, can see is a world that makes P or Q true. But neither one of the disjuncts is itself necessary, because in one case, it is Q that makes the disjunction true, and in the other case, it is P. So there you have it, the proof of K4. We'll stop this video here, come back and prove the next theorem in the next one. Hope to see you then. Take care. Cheers.